Hi, this is Wang. Today we are going to talk about the water ladder, which is a hard problems in the lead code. And it's a classic Bradford search problems. And I just suppose you understand the problems correctly. And so let's just see, see this problem in details. Actually, there are two corner cases we should first take into account. First one is that if the begin words is just equal to the end word, which means that we should just return 0. And the second corner case is that if the inner word is not in the word list, which means that it's impossible for us to change the begin words to the end word. So we should also return 0. And during the process, we are changing begin words to some new words that in the word list. So we can just find some patterns of the words in the word list. For example, here for the dog, actually there are three patterns we can consider. The first one is OG and D star G and D O star. And the star here is denoted for the characters from the A to Z, and we can replace the star with any characters from A to Z. And this is the patterns. And we should create a hash map which stores the key with the pattern, and the value should be a list of the original word. For example, here, the DOG will be the key, and the dog will be element in its values. And so during the BFS part, we just start with the begin words, and we just change the begin words into the patterns, and to find which kind of the words that we can reach from the begin words. And if it's equal to the end word, we just return. And because we are supposed to return the number of the words in the shortest transformations of the sequence, and it's also included the begin word. So we will use the variables that start from the 0, from the 1 because it includes the begin word, and use EQ. First, we'll just create the hash map. It's our default list, which is a list, and for words in word list, and for the pattern should be the word index as star or star as +1, and we do not need to consider all of the boundaries, because in Python, if this one is greater than the length of the words, it will just return the empty. So we just create a pattern, repeat, append the original word, which is W. So here by writing those kind of the codes, we will build up our patterns. So let's just start. So Q, and also we should keep track. There are a lot of the repeated the word that cannot be reached um to the um to the end words. So we just use this kind of the set to denote those are the end words. Here we just created the pattern set made from this current word, the power from the queue. Mm, copy like that. And for next word in pattern B, if not, if next not in here every time before we transform, we should update it by plus one. Um, if it's equal to the end word, we just return the stuff, and if not, we will just add it to our and append to our queue. Just if not, we can just return 0. Let's go through the logic and mm, these are two core cases. Here we just build the hash map that the key is the patterns and so the values should be a list of the words that can be changed from those kind of the patterns. Um, I will start with the beginning word, and every time we just before enumerations, we just update it step by plus one and pop the first element from the queue and create the patterns from the current word and go through its neighbors and of the patterns. So this is to check which kind of the words we can reach from the current pattern. And if it's not in the visited, we can just we double check whether it's to the n word. If it's equal to the n word, which means that we should return the step. If not, we can just add our um, to our queue and also append to our visit. Yeah. Um, where to I think this is just if not. Hmm, I'll return to. That's a little bit weird. Yeah, I think this should be current. I just yeah. Yeah, that's pretty much about this. Oh, thanks for watching.